familiar-looking landscape, rich with resources.
Some believe Mars is the next home for humanity.
A frontier of freedom and prosperity.
And a backup copy of civilization in case of disaster here on Earth.
But the real red planet is a trickster with a long history of fooling us.
Once thought a mythic place of exotic, intelligent creatures.
The true Mars is a failing world, much colder than Antarctica, bone dry, with a harsh, toxic landscape.
We may soon have the means to get there.
But will we live there?
For thousands of years, Mars has been trying to tell us something.
Earth and Mars come closest together every 780 days or so. Called a planetary opposition, it's the best time to observe the red planet, which appears to slow down, backtrack, then speed forward again.
Puzzled by this capricious motion, Egyptian skywatchers personify Mars as a hawk-headed humanoid deity, flying back and forth between the realms of the living and the dead. Babylonian astrologers believe Mars to be a quick, impulsive, volatile god.
Observing the moon pass in front of the red planet, Aristotle deduces that Mars must be higher up and farther away than the moon. But he would have been surprised by how much. Mars is about 200 times more distant. Chemical rockets that take around 3 days to get to the moon would take nearly 7 months to reach Mars.
Future nuclear thermal rockets could cut that to less than 3 months. But even that is a very long time to spend confined in a spacecraft far from Earth, even with comfort foods along. And you can't just return home in a few hours if there's a problem.
Astronauts in microgravity must exercise often. Bones become brittle. Heart muscle gets lazy. How will Mars' 1/3 gravity affect human health over the long term?
Greek mathematician and astrologer Claudius Ptolemy proposes that Mars and the other 4 wandering stars must circle Earth on a set of spheres.
Around 850 AD, Islamic astronomers begin to find problems with Ptolemy's epicycles.
But it will take another 7 centuries for the truth to surface in Europe.
In 1543, Copernicus of Poland finally puts the sun at the center of motion. Now, Mars' looping behavior makes sense.
Wealthy, obsessive Danish astronomer Tycho Brahe likes Copernicus' geometry, but can't quite let go of Ptolemy. Tycho insists the massive Earth is too lazy to orbit.
But massive worlds do move. In the early solar system, Jupiter may have moved toward the Sun as far as Mars' present-day orbit, gobbling much of the inner solar nebula's dust and gas, robbing Mars of its potential. The stunted planet could grow to only about half Earth's diameter and barely 11% its mass.
Tycho is a compulsive data taker, but it will fall to his research assistant, Johannes Kepler, to make sense of Tycho's numbers.
Kepler bets a friend he can plot Mars' orbit in 1 week. After 5 years and 40 attempts, he finds that all planetary orbits are elliptical, putting the last nail in the coffin of Ptolemy's crystal spheres within spheres.
As the early solar system evolves, Jupiter and Saturn displace billions of tons of icy rocks, flinging them inward. A deluge of debris lasting 3 million years. The Late Heavy Bombardment.
Today, the high country of Mars' southern hemisphere has one very large hole punched in it. The Hellas Basin, the third largest impact crater in the solar system. Its floor lies 10 kilometers below the heights of the nearby South Polar Cap. But Mars may have been hit by something even bigger near its opposite pole. As you fly from south to north, the height of the landscape sinks, seen here going from red and orange highlands down to green and blue valleys. Mars' whole northern hemisphere is a sunken ellipse, draping over 40% of the planet.
If this is an impact site, the incoming object would have been about the size of dwarf planet Pluto. It would have totally remade Mars, possibly shutting off its internal dynamo, erasing its protective magnetic field, and killing the chances for a life-sustaining atmosphere.
Galileo Galilei makes the first telescopic observation of Mars. He says he's afraid it isn't round.
Francesco Fontana creates the first known drawing of the planet, saying it looks like a very black pill, probably due to flawed lenses in his spyglass.
The Dutch brothers, Christian and Constantine Huygens, are innovating better optics.
Christian sketches an irregular mark on Mars. Living in the wetlands of Holland, he thinks it looks like a big bog. So it becomes known as the Great Marsh, Syrtis Major.
Huygens uses that shape to measure Mars' day length, finding it to be about the same as Earth's. Giovanni Domenico Cassini refines that figure to 24 hours plus 40 minutes, very close to what astronomers measure today. He also logs the first observation of Mars' South Polar Cap, drawn here by his friend Huygens.
Cassini imagines that Mars is similar to Earth.
"3 billion years ago, Mars may indeed have been Earth-like. Volcanoes building the atmosphere. Steam and mist and flowing water. Filling early oceans with more fluid than the Arctic Ocean on Earth.
The first Mars rover, Little Sojourner, the Pathfinder, lands in the outflow of what must have been a cataclysmic flood.
The Mars exploration rovers, Spirit and Opportunity, find stacked strata of rock laid down by flowing water over thousands of years, and little rounded iron-rich concretions, nicknamed blueberries, that formed in cavities of silt under salty water.
But is there any water near the surface of modern Mars?
In 2008, NASA's Phoenix finds evidence. Soft landing in the high northern latitudes, its rocket plumes blow away surface dust, exposing some white material. The little probe digs a shallow trench, revealing more. It disappears in a day, proving it was water ice. And on the lander's legs, drops of liquid appear, then change. The Mars Science Lab, Curiosity, rolls through dry stream beds, between the banks of ancient watercourses, and across fans at the mouths of long-dead rivers. The robot geologist sees a range of layered landscapes. Each was built by episodes of flowing mud, with dry times in between.
Today's Mars seems a lifeless desert. A lonely landscape, crying out for company.
Elon Musk's space exploration company hopes to end Mars' long isolation. SpaceX begins building a constellation of satellites, eventually numbering almost 12,000, orbiting unusually close to Earth, to move data much faster than today's wired internet, and to raise money for making life multiplanetary.
Huygens. Though Christian Huygens has died, his final book, Cosmos Theoros, will excite future generations. Huygens argues that the moon and planets harbor intelligent beings. But do the other planetary worlds of our solar system truly have what it takes to be habitable?
The moon is rich in aluminum, titanium, silicon, and magnesium. Asteroids add carbon, cobalt, platinum, molybdenum, nickel, and other elements. Mars has all of these, plus abundant iron and many other metals, especially near its enormous volcanoes. But the key is water. It can be split to make breathable oxygen and hydrogen fuel. The Mars 2020 rover will test this idea. It'll breathe in carbon dioxide and electrochemically break out oxygen to see if rocket propellant and life support can be made on Mars. Water from beneath the surface and carbon dioxide from its atmosphere can be rearranged to make methane and oxygen.
Burn the methane using that oxygen, and you can launch rockets. Make that propellant on Mars, and you can drop the cost of getting back to Earth by a factor of at least 5. Exactly what SpaceX has committed itself to do.
To conjure up space-based civilization, launch only what you need to live off the land: tools and talent and factories and power generators.
If everything for space has to be built in pieces on Earth, then trucked up from the bottom of our deep gravity well, and tediously fit together on orbit, we'll never get anywhere.
Giacomo Filippo Maraldi guesses that dark rings around Mars' poles might be melted material. Could the poles be ice caps?
80 years later, Friedrich Wilhelm Herschel declares, yes, Mars poles are water ice. And he thinks the broad, dark equatorial patches are oceans. The large Syrtis Major feature has come to be called the Hourglass Sea. Herschel and his contemporaries dream of what it might be like to sail those waters.
Mars may have lost its oceans long before life on Earth emerged. The northern desert lowlands, the flattest terrain on any planet or moon, look like the floor of an ancient sea, up to 4 kilometers deep. Mars' polar ocean may have covered a third of the planet.
In 1785, Herschel speculates that Martians probably enjoy a situation similar to our own. But he reports Mars' atmosphere must be very thin.
It is thin. The planet is enveloped in sparse carbon dioxide. There's very little water in the air. But there's plenty not far under the crust. Mars also makes tiny amounts of methane, which could be coming from hot geology.
But those methane levels seem to bloom in certain seasons. And that has a lot of experts wondering, might there be life below the surface? Johann Hieronymus Schroeder believes Mars has no solid surface at all, just drifting clouds and misty rain. He thinks he sees sweeping atmospheric changes right before his eyes.
Schroeder's shifting scene probably is due to an atmosphere, but it's the unstable air of Earth above his telescope that has spoiled his seeing.
The true story of Mars' atmosphere is becoming clearer. Go back at least 1 billion years. Intense ultraviolet radiation from the sun and the sputtering solar wind are bombarding the small planet.
With its low gravity and frail global magnetic field, Mars can't hold on to its protective gas envelope. Most of its air and much of its water are lost to space.
Back in 1830, however, none of this tragic history is yet known. Johann Heinrich Madler and Wilhelm Beer make the first truly accurate Mars maps. They place their longitude 0 line through a feature that will later be named Sinus Meridiani, Meridian Bay.
The Mars rover Opportunity is working there right now.
In images, Mars looks like a picturesque desert. It's easy to imagine yourself standing there, gazing at the intricately weathered rocks. Nearly everywhere you look, you see evidence of past liquid water.
Though there are no oceans today, there's plenty of ice. The Mars Reconnaissance Orbiter records eroded cliff faces, exposing compacted water ice, in some places more than 100 meters thick. On passes over the poles, MRO's radar reveals up to 2 kilometers of ice. It seems to have been laid down in layers.
Does Mars' climate cycle between warm and cool? Orbiting spacecraft have watched dark streaks appear over time, usually on the steeper slopes of craters. They look just like desert gullies on Earth. The markings change with Mars' seasons. Many researchers thought they might be flowing salty water.
New analysis suggests at least the larger ones are dry. Streams of rounded sand grains tumbling over one another, flowing like liquid in the low gravity of Mars. But the small ones seem truly wet. Another slippery Mars paradox.
Astronomer Camille Flammarion picks up the intelligent alien torch and runs with it, eventually publishing 8 books on the topic. The Plurality of Inhabited Worlds becomes an all-time bestseller. With the publication of Charles Darwin's Origin of the Species, Flammarion has realized that differing conditions on various planets should cause creatures on them to be unlike those of Earth.
The building blocks of life are, in fact, plentiful on Mars. Curiosity has found abundant oxygen, carbon, nitrogen, phosphorus, and sulfur, as well as complex organic macromolecules. Clay minerals would have filtered salts and harsh compounds from the primeval flowing waters. Many microbes now living on Earth would likely have survived on early Mars. But no photos, fossils, or chemical evidence of life has yet turned up.
The Vatican becomes concerned about the state of grace of the Martians. Father Pietro Angelo Secchi of the Roman College Observatory starts to chart where they might live. He gives the Hourglass Sea a new name, calling it the Atlantic Canale. That word simply means channel. Secchi intends no reference to intelligent design. But his term, canale, will cause much confusion in the coming decades.
Over in England, astronomer William Dawes is making Mars maps of his own. He's extremely nearsighted, but his charts are more detailed than any made before.
Smelling a great story, science writer Richard Anthony Proctor blasts the Dawes maps out to the public.
The Suez Canal is completed in November of 1869, making news around the world. The Panama Canal is being planned.
Many people make a connection between the straight canali on Mars maps and these great works of engineering on Earth.
There are, in fact, many ancient water channels all over Mars, but there's no evidence of technology in their shapes.
Mars comes once more into opposition. But this time, many new telescopes are pointed at it.
One belongs to Nathaniel Green on the island of Madeira. An artist by day and astronomer by night, Green paints the most accurate Mars chart yet.
Over in America, the self-taught astronomer Asaph Hall sees something no one else has. 2 tiny moons.
Phobos and Deimos may be bits of Mars, flung into orbit by giant impacts long ago. Or they may be asteroids captured by the planet's gravity.
As Mars comes close, within 56 million kilometers of Earth, Giovanni Schiaparelli is ready.
Though he, like Dawes, is nearsighted and colorblind, Schiaparelli is able to extract more from the telescope than others.
He too calls the lines he sees on Mars canali, and he gives them whimsical names from classical literature, like Pyrrhus, Cerberus, and Pyrrhithlegathon, labels still used by Mars mappers today.
Why are some Mars oppositions closer than others? While Earth's orbit around the Sun is nearly circular, Mars' orbit is much more elliptical. Only Mercury's is more eccentric. During Mars' southern autumn and winter, that hemisphere is tipped away from the Sun, and the whole planet is farther away, making those seasons longer and colder.
Another close opposition, and Schiaparelli comes to believe he's seeing pairs of straight canali. Harvard College Observatory's director, William Henry Pickering, declares the canals of Mars are only rendered visible by plants growing along their banks and the surrounding land.
Any science-based speculation about large engineering projects by smart Martians will die abruptly on the night of July 14, 1965, as NASA's Mariner 4 flies by Mars.
In the probe's 21 images, Mars looks much more like the Moon than the Earth.
And worse, Mariner can't find a protective magnetic field. Harsh solar wind and cosmic radiation scour the planet. It's hard to imagine how even primitive plant life could survive here. And water seems to have flowed only in the ancient past.
Back in 1892, Camille Flammarion has filled his imaginary Martian canals with water, speculating they may be the rectification of old rivers by the inhabitants for the purpose of general water distribution, and the actual habitation of Mars by beings superior to our own is very probable. Pickering adds fuel to Flammarion's fire, asserting that he has seen 40 lakes.
At about the same time, a wealthy, world-traveling American diplomat is feeling like he needs a career change and a personal passion project. Percival Lowell has read Flammarion's books, and he makes plans to look for Martians during the coming opposition of 1894. Pickering helps Lowell rig 2 telescopes on a hilltop in Flagstaff, Arizona. The new Lowell Observatory is trained on Mars all summer long.
At the telescope, Lowell sees what he believes and sketches a complex irrigation system, transporting billions of gallons of melted polar snow to equatorial desert oases. The irrigated agriculture projects of an advanced race.
But during the same opposition, Edward Barnard, wielding the California Lick Observatory's larger refracting telescope, cannot find a single straight line anywhere on Mars. And when the Lick's William Campbell examines Mars with a spectroscope, he sees not a trace of water in the atmosphere. English astronomer Edward Maunder demonstrates how straight lines on Mars could be optical illusions.
Undeterred, Percival Lowell sprints across America on a lecture tour, promoting his book named simply Mars. A story-thirsty public buys his tales of Martian waterworks by the thousands.
The real Mars is a parched planet. Though tilted rocks tell us there were lakes here long ago. With no liquid water to irrigate plants and no plants to hold the soil, dust devils swirl across the barren terrain. Curtains of desiccated grit sweep up into the hazy sky from rugged canyon cliffs. Sandy landslides garnish steep crater walls and clump on the floors.
Percival Lowell begins observing with an even bigger refractor, but still cannot see his glaring error. Lowell will carry on for 20 more years, inventing over 450 canals with vegetation. He pictures a desperate civilization, bravely combating global climate change, as their dying world dries to a planetary desert.
In fact, Mars' climate did change radically. But it happened long before Lowell's time. Without a large moon to stabilize it, Mars wobbles tens of degrees over hundreds of thousands of years, much more radically than Earth. When Mars points a pole toward the sun, billions of tons of CO2 are released, unleashing epochs of greenhouse warming, melting subsurface ice, flooding the planet.
H.G. Wells publishes War of the Worlds. A dying race of Martians wants to conquer Earth to make it more like Mars.
In 1976, Earth will send 2 Viking landers, not to subjugate, but to investigate.
ATS is green, 1.5 degrees per second max, 0.2 Gs. Feet per second. Touchdown, we have touchdown. Exit zone.
They will find very active, intriguing surface chemistry, but no obvious life.
But back in 1905 at Lowell Observatory, Carl Lampland claims he's photographed 38 canals.
Alfred Russel Wallace, who originated the idea that natural selection drives evolution, realizes that craters observed on Mars must be the impact sites of large meteorites. Rovers Opportunity and Curiosity find several small impactors sitting right on the surface. These rocks from the sky tell a story of a planet with a thick atmosphere long ago. At the Meudon Observatory near Paris, Eugene Antoniadi realizes there are no straight canals on Mars.
American novelist Edgar Rice Burroughs releases the first of his 11-volume tale depicting heroic John Carter on a fictional Mars, the desert planet Barsoom.
You are ugly, but you are beautiful. You will fight for us!
A century later, Disney director Andrew Stanton will bring it to the screen.
Curiosity's Mars is a desert world too. The rover treks around a wide field of dark sand dunes. Rolling like waves on an ocean, the sandy mounds slowly migrate across the landscape. Mount Wilson Observatory astronomers measure surface temperatures on Mars, finding them to swing wildly.
They range from 15 degrees Celsius at midday to minus 85 degrees Celsius just before sunrise. Russian filmmaker Yakov Protazanov makes Aelita. An Earthman flies by rocket to lead a revolt against the rulers of Mars and win the love of the Martian Queen.
But the prospects for civilization on the planet grow dim, as astronomer Walter Sidney Adams can find only vanishingly tiny quantities of oxygen and water in the Martian atmosphere. At Yerkes Observatory 13 years later, Gerard Kuiper detects abundant carbon dioxide.
Rocket pioneer Wernher von Braun writes Project Mars.
It's a sci-fi novel, but full of factual engineering.
Ray Bradbury's Martian Chronicles puts a human colony on Mars to escape a nuclear war-devastated Earth. The movie Rocket Ship XM pits a stranded astronaut crew against Stone Age humanoids, remnants of a Martian global nuclear war.
You must get back to Earth. Tell them what we found.
The first thermonuclear bomb is tested. In the same year, von Braun publishes Das Mars Project, a comprehensive technical workup for a large-scale space program that will become the blueprint for NASA's Mercury, Gemini, and Apollo projects.
In 1955, Paramount Pictures releases Conquest of Space.
It, too, is based on von Braun's planetary plans.
I can give you a confounded little reason for this attempt to reach Mars, and no assurance at all that it will even be successful.
At Los Alamos National Lab, Project Rover begins. It's an effort to harness nuclear fission to drive spaceships at constant thrust. Project Orion, a different approach to nuclear rockets, starts testing hardware. The idea is to detonate atomic bombs behind a ship to push it along. It's called pulsed plasma wave propulsion.
Outrageous as it seems, this method could offer rapid transport to Mars and the rest of the solar system.
The U.S. Nuclear Engine for Rocket Vehicle Application, NERVA program, accumulates 17 hours of live engine test time.
It raises hopes for Mars missions and moon bases.
In the Soviet Union, engineers are working on nuclear thermal rockets of their own.
Soviet leaders have the specific goal of making Mars a politically red planet.
The Soviets try several times to send probes to Mars,
but they get no closer than 197,000 kilometers and achieve very little science.
Someday, a manned trip to Mars and return may become the mission assignment.
To answer that challenge, Kraft Ehricke, a visionary German-American engineer, introduces the idea of ganging together clusters of nuclear rockets.
He argues that his modular approach could bring Mars and Venus within reach as early as the 1970s. Ehricke passionately believes that human expansion throughout the solar system is a fundamental right.
And that we are at our most dignified when we apply the laws of physics to elevate and protect human freedom. Just days before Apollo 11's lunar landing, a monstrous moon-bound Soviet N-1 rocket rises 200 meters, only to shut down and crash, completely destroying its launch pad.
It is one of the largest non-nuclear explosions that humans have ever made.
The N-1 might have ferried 6 cosmonauts on Mars missions lasting 630 days using nuclear-powered upper stages.
But when the US wins the moon race, the Kremlin's interest in the red planet seems to evaporate.
Mariner 6 flies within 3,437 kilometers of Mars' equatorial region this same year. And Mariner 7 sails past Mars' south pole, finding the temperature a chilly minus 125 degrees Celsius.
With 2 moon landings fresh in mind, the public expects NASA astronauts to go on to Mars.
Say again, please.
But when Apollo 13 nearly ends in disaster,
Houston, we've had a problem.
President Richard Nixon fears the political consequences of another failure and tries to end the moon voyages.
Mariner 9, the first craft to orbit another planet, finds conclusively: Mars has no canals, no cities, no forests, no lakes.
I was strolling on the moon one day.
As Apollo winds down, von Braun proposes that Saturn V rockets lift the pieces of a pair of reusable nuclear-powered ships. They would carry orbiters and surface expedition vehicles across the Great Void to Mars.
But Nixon shrinks the budget to only a space shuttle, confining the human space program to low Earth orbit for what will turn out to be half a century.
In that time, 4 United States presidents will ask for Mars-related programs. But none will get much further than the planning stages. There's growing suspicion among space advocates that large government space programs might be too slow and inefficient to ever get to Mars.
Engineers Robert Zubrin and David A. Baker propose Mars Direct. Travel light, they say, and live off the land. By making rocket fuel from the planet itself, explorers could ensure themselves a ride home.
By 1993, key ideas from Mars Direct are finding their way into NASA's Mars Design Reference Mission. NASA will update the design 4 more times. But consistent support for a direct, affordable approach never fully materializes.
It's the private sector's turn. The Mars One company starts taking applications for one-way journeys to colonize the planet.
So-called Mars-to-Stay programs could dramatically reduce travel outlays. But at what cost in human terms?
The big established aerospace companies prefer to bring their crews back. Boeing's affordable Mars mission would send a solar-electric sailing ship to reconnoiter from low orbit. When all is ready, explorers would descend, protected by an inflated aeroshell, touching down like the Apollo missions to find a previously landed habitat waiting. They'd return like last century's moonwalkers for the long trip home.
Lockheed Martin proposes a Mars-orbiting base camp. It's smartly built by stacking pairs of modules. 2 habitats, 2 tank farms, 2 rocket propulsion units, redundancy for safety far from Earth. Astronauts make sorties to the surface with a single-stage lander. But this surface-to-orbit shuttlecraft doesn't depend on fuel made on Mars.
Elon Musk goes public with his plan to settle Mars. SpaceX has been developing a big reusable booster, the Falcon Heavy, which could launch Apollo-style missions. Blue Origin, led by Amazon founder Jeff Bezos, has been quietly developing large boosters of its own. Blue intends nothing less than extending civilization into space.
Elon Musk supersizes his already large vision. SpaceX will build a big Falcon rocket. It's designed to quickly fly between points on Earth, haul massive payloads around the solar system, and to transport people, as many as 100 at a time, to the surfaces of planets, asteroids, and moons. And of Mars, SpaceX envisions complete terraforming of our neighbor world. Dream projects like these may make it to Mars, but the old trickster planet lies in wait.
Its surface is loaded with toxic, caustic perchlorates, the chemicals that give fireworks their bang. And with a constant rain of cosmic rays and solar flares hurling highly energetic particles, settlers would have to spend most of their time underground.
Might it be better to investigate Mars through augmented reality? Or teleoperated robots? Artificial intelligence?
Perhaps machines smart enough to terraform Mars on their own.
Pioneers of the future could find a more comfortable planet ready-made for them. In 2033, Mars will come into particularly favorable positioning for launching human exploration. Will we be ready to answer its call?
Of nearly 50 missions launched to Mars, more than half have failed. The ones that succeeded conveyed the indelible impression of a desperate, struggling planet.
The technically engineered salvation of this desert world, as imagined by Percival Lowell, may yet come to pass.
But if Mars is to live again, it will be up to us. We face a long, difficult battle to reboot an entire world.
And Mars will, no doubt, change humanity.
Even as humans change Mars.